Hello, you're welcome to our lecture series on chordates. Earlier in this series, we had looked at the Pisces, and we said the Pisces basically referred to a group of vertebrates or fish-like vertebrates, mainly the fishes. And we had classified the Pisces into two superclasses in the phylum Chordata. And those two superclasses are the superclass Agnatha or Agnatostomata and the superclass Gnatostomata. And we said in the superclass Agnatostomata, we have the jawless vertebrates, vertebrates that lack jaws. And those vertebrates, extant members of that superclass, belong to two classes. The classes Myxini, which has the hagfishes, and Cephalospidomorphi, which has the lampreys. And we've also looked at the superclass Gnatostomata, which we said is a class that's having jawed vertebrates, vertebrates that possess jaws. And in that superclass, we have the extant classes as follows. The superclass Sarcopterygi, the superclass Actinopterygi, the class Actinopterygi, the class Sarcopterygi, and the class Chondrichthyes among the Pisces. Then we have other jawed vertebrates like the amphibians, the reptiles, the birds, and the mammals. We have successfully discussed the class Chondrichthyes, which has the sharks and the rays, which are mainly cartilaginous fishes. Today's lecture will be on the bony fishes, and the bony fishes are classified into a group known as the Osteichthyes. The Osteichthyes has two classes. The classes Actinopterygi and Sarcopterygi. So we want to now look at the details of this group. The Osteichthyes are ray-finned fishes. They include both ancient and modern bony fishes. The Osteichthyes can be divided into the classes Actinopterygi and Sarcopterygi, as mentioned earlier, the two classes in this group Osteichthyes, which are bony fishes. They are classified into Actinopterygi and Sarcopterygi. The group is named for their bony skeletons, although that is not true for all. There are some that do not have bony skeleton or that are not entirely made up of bony endoskeleton. They have membranous fins supported by bony rays, membranous fins that are supported by bony rays. They have an operculum, unlike the chondrichthyes that do not have that have several gill clips and do not have operculum covering the gills, apart from the holocephali, the chimeras. This group of organisms or the fish, this group of fish in the group Osteichthyes have operculum. They also have scales, very conspicuous and big scales that are known to grow throughout lifetime, unlike the chondrichthyes that have scales that do not grow throughout lifetime. Now I want to look at the class Actinopterygi, which has the ray-finned fishes. This is the most diverse group of vertebrates. In fact, the group is known to contain all popular fishes that we eat in our restaurants, that we prepare to eat in our kitchen, that's we eat in our dining tables, and so many fishes that are being sold in the market belong to this group. These fishes possess stream bladders and bony endoskeletons. Their paired fins are supported by fin rays, the bony rays, and the paired fins are the pelvic and the pectoral fins. The pelvic and the pectoral fins, which are the paired fins, are supported by bony fin rays. The class Actinopterygii, that's the bony fishes, consists of three subclasses. And the three subclasses include the subclass Teleostei, the subclass Chondrostei, and the subclass Neopterygii. Want to discuss the subclass Teleostei, which are also called teleos. The subclass Teleostei consists of a large, extremely diverse group of ray-finned fishes, along with the Chondristians and Holestians. They are one of the three major subdivisions of class Actinopterygii, the most advanced bony fishes. Teleostei include virtually all world's important sport and commercial fishes, as well as much larger number of lesser known species. The subclass is distinguished primarily by the presence of homosexual tail. That's a tail, one in which the upper and lower halves are equal, just as it is in this barracuda. The lower tip of the tail and the upper tip and the lower tip are equal. That's said to be homosexual, unlike that of the shark, in which the lower tip of the tail is shorter. The teleosts comprise some 20,000 species. That's about equal to all other vertebrate groups combined, with new species being discovered each year. Now, these are typical examples of the teleosts, mostly found in the ones that are found in Nigeria. These were collected from the non-river estuary in Bayelsa State, Nigeria. And this one was collected from the River Non, also in Nigeria. Now, here is if another class we want to discuss, the subclass Chondrostei, a subclass Chondrostei. This group of osteichthyes have few extant species. Today they are represented by only the paddlefish and the sturgeons. They have an endoskeleton composed mostly of, but not exclusively, of cartilage. Their endoskeleton is made mostly of cartilage, unlike other bony fishes that are made up of bone. This is the American paddlefish, of the subclass we have discussed about. Now, I want to look at the subclass Neopterygii, which has the jars and the bowfins. This division represents another primitive group of fishes having few extant species, the gars and the bowfins. Unlike the Chondristians, their skeleton is mostly ossified. They have bony skeleton. A distinct feature of this division is their scales that are ganoid scales. Ganoid scales are bony and diamond-shaped scales. They have such ganoid scales in their skins. Now, this is the figure of a gar, and this is an alligator gar, looking exactly like an alligator. Okay, they all belong to the subclass Neopterygii. Now, want to look at the class Sarcopterygii. The class Sarcopterygii has the lobe-finned fishes. This is a group of bony fishes having a fleshy lobe on their paired fins. They have internal nares that open internally into the oropharyngeal cavity. They possess a gas-filled air sac. The lobe-finned fishes are largely extinct group of fishes. The group consists of only approximately 8 extant species, including the African lungfish that's displayed on this slide. The Sarcopterygians have two others, and the others are Actinistia and Chrysopterygii, which has the coelacanths. The Actinistia or Chrysopterygii, which have the Actinistia, the coelacanths, and the other Rhipidistia that have the long fishes. So the two others are the other Actinistia or Chrysopterygii and the other Rhipidistia, which belong to the class Sarcopterygii. Now, the other actinistia or Crossopterygi, these are represented by the coelacanths. The coelacanths are deep sea fishes of the family Latimeridae. The name refers to the hollow fin spines. It's derived from the Greek word koilos, which means hollow, and acantha, which means spine. Coelacanths are powerful predators with heavy muciliginous bodies and highly mobile limb-like fins. They are predaceous organisms. They are serious predators feeding on fish, and their bodies are covered by mucor, and they have highly mobile limb-like fins. These are their fins. They are like limbs, and they are highly mobile. They average 5 feet, that's 1.5 meter in length, and weigh about 100 pounds. That's 45 kilograms. This is a coelacanth, and just as it has been described, the coelacanth has limb-like fins. The fins are like limbs. The next order I want to talk about is the order Rhipidistia, which has the lungfishes. Rhipidistians or lungfishes are air-breathing fishes. The extant species occur in rivers and lakes in Africa, South America, and Australia. The African lungfish that is found in Nigeria is called Protectorus annectans. Most species grow to substantial sizes. Of the African lungfishes, the yellow marbled Ethiopian species, Protectorus ethiopicus, is the largest, growing to a length of 2 meters. That's about 80 inches long. The African lungfishes are slim, eel-like in shape, and they have even slimmer species, the South American Lepidosirene, or they have long, stingy, very mobile pectoral and pelvic fins that are in constant state of agitation, touching and sensing the surroundings. The tips of these fins have a highly developed sense of touch. The tips of the pectoral and pelvic fins have highly developed sense of touch. The fish are almost blind with respect to perception of form and movement. Pressure and turbulence are sensed by means of sensory structures called the lateral lines. The Australian lungfish has entirely different appearance. It is more compactly built and has large overlapping scales. The pectoral and pelvic fins are much broader than the African lungfish that have been described earlier. The African and South American lungfishes have paired lung sacs. In the Australian species, the left lung sac atrophies. The left lung sac is smaller than the right one. This is Protectorus annectan, the African lungfish, collected from ponds in Nigeria, Bayelsa State. Adaptations for breathing. The lungs in lungfishes are primitive, like those of amphibians, both in function and structure. The name lungfish is thus well applied. These fishes have sac-shaped pneumatic organs that lie along the alimentary canal. They have lungs, okay, and the lungs are around the alimentary canal, and they use the lungs for breathing. The lungfish would have to come out to breathe air on the surface of the water, atmospheric air, instead of dissolved oxygen. The inner surfaces of these air-breathing organs are covered with a great number of honeycomb-like cavities covered with fine blood vessels. As in terrestrial higher vertebrates, gas exchange takes place in the tiny air vesicles. So gaseous exchange takes place in the lungs. They breathe atmospheric air instead of dissolved oxygen. Now, this is the lung of the African lungfish. which is used for respiration. It wraps around the alimentary canal. And these organisms also have a notochord are still found in the adults. And this is the liver. In order to breathe, the fish swims upward and positions its head so that the tip of the snout barely touches the water surface. The mouth is then opened wide and the fish sucks in air from just above the water, a process often accompanied by a characteristic sound. The Australian lungfish reportedly breathes air through the nasal openings. The mouth remained closed. So the Australian lungfish, instead of using the mouth to breathe air, it uses nostrils to breathe. In contrast to higher bony fishes, lungfishes have a particular opening that's called the choana that connects the nasal cavity with the mouth. We want to look at the reproduction and life cycles of the lungfishes. The African lung species spawn in the onset of the rainy season. Protectorate species build a nest in the form of a pit on the bottom of a watercourse. The tiny larvae emerge a week after the eggs are laid. The larvae have long, bright red, tusk-like or fin-like external gills, which they use for breathing until the lungs are fully developed. So the larvae make use of external gills for breathing, just as it is in some tadpoles of the amphibians. But when they become adults, they develop lungs for breathing. That's one important feature that's found in the African lungfishes. The Australian lungfish lays gelatinous eggs among aquatic plants. The larvae, which have no external gills, breathe through internal gills. And when they become adults, they use lungs. Behavior and ecology. Lungfishes are voracious, eating a variety of aquatic animals, including members of their own species. In captivity, African lungfishes eat earthworms, pieces of meat, tadpoles, small frogs, and small fish. The Ethiopian lungfish has at the front of the upper jaw two rather rounded teeth with a hard transverse bridge. Okay, the transverse bridge has a transverse bridge. The lower jaw has a number of crushing teeth. The prey is sucked in, crushed, and thoroughly chewed. Such a manner of eating is rare among fishes. They don't, fishes only swallow their prey, but in this case, the Ethiopian lungfish chew their prey just like it is with some mammals and basically with the mammals here. Want to look at one very important feature of the lungfish, that's estivation or hibernation. What's estivation? Estivation means when a fish or any other organism goes into a state of dormancy. It shuts down, breaks down its metabolic activities when the climatic conditions are not favorable. They remain in that dormant state until conditions become favorable. To estivate, the African lungfish bore into the bottom of a river bird or lake bird. After burying themselves, they become encased in a sheet that gradually hardens, a cocoon. They create a cocoon. Here they spend the dry season, during which the waterline becomes lower and the river bird or lake bird finally dries out. Okay. They remain alive in such an induced state for more than 2 years. They can remain in that state for more than 2 years. So you can see how wonderful they are made. Though usually in most cases, they hibernate or they estivate to survive the dry season. During the rainy season, they come out. But in extreme drought condition, when there's extreme drought, they can remain in that state for more than 2 years. The African lungfish generally digs in and exists in this manner, even if there is sufficient time to swim to deeper waters. African lungfishes also burrow into mud and then shit themselves under experimental conditions. They have been kept alive in such an induced state for more than 2 years. So that's basically how it estivates. This diagram looks at how the estivation takes place. While the water is still there, while it's drying out, the lungfish burrows into the soil and then it creates a cocoon that hardens and then it remains in this dormant state until the dry season passes. At this point, the water had dried up, okay, and it remains in this state throughout the dry season. When there's sufficient water in the rainy season, it comes out to survive. Thanks a lot for watching this episode of our lecture on chordates. The next one will be on amphibians. Please keep watching.